Okay, guys, on page 8, we're going to go over compound inequalities. Now, and Siddharth show up? No, okay. A compound inequality consists of two inequalities that are connected by the words and or. And there's a big difference between whether it's connected by and whether it's connected by or. When it's connected by and, that means both compound inequalities must be true. Now, there's one other thing I want to go over before I go over and or, and that's the word between. Okay, now the word between, there's a big difference between the word between and between inclusively. If I say you have to be between the ages of 5 and 18, technically that means if you are 5, you are not included. There's Siddharth. Okay, I'm going to have to change attendance. If you're between 5 and 18, that means 5 is not included, 18 is not included. The word between means do not include the two endpoints. So if X is between 5 and 18, it's written like this. X is in between 5 and 18. Notice there's no equal sign here. So this is an open dot, this is an open dot. And if X is between, those are two open dots. But if I say X is between 5 and 18 inclusively, that means this is less than or equal to, this is less than or equal to. When I draw it, I fill in the dots for both. Okay, now, as I said before, you can have an and inequality and an or inequality. We're going to go over both, but we're beginning with and. And inequalities can be written with the word and without the word and. You will find that or inequalities, you have to have the word or. So this is equivalent to this. This can be read as X is in between 5 and 18. This can also be read as X is greater than 5 and X is less than 18. And they mean the same thing. Okay? So, who thinks they can tell me how to write this next one using the word and? Who can tell me how to write that? Okay, I will just do it. So this means X is greater than -2 and X is less than 13. Now this one, which was written as X is greater than 5 and X is less than 32, that means X is in between 5 and 32. You can see here X is greater than 5, and here X is less than 32. Okay? So we can write these with the word and. You can, when you have and inequalities, they can be written with the word and or without the word and. Okay, now, okay, here I want you to rewrite each compound inequality without using the word and then graph the solution set. So for number 1, it says X is less than 9 and 0 is less than X, or that could be written as X is greater than 0. So X is less than 9 and it's greater than 0. Well, that means X is in between 0 and 9. See, X is greater than 0, this is x is greater than 0. X is less than 9, this is x is less than 9. So an and inequality can be written without the word and. Now, to graph this, we are going to graph what we call our critical points, 0 and 9. So these are 3 different lines. First, I'm going to graph x is less than 9. So that would be an open circle, and I would go this way. Then I'm going to graph x is greater than 0. This would be an open circle, and then I go this way. Now, the compound inequality is the combination of the two. It's the union of the two. It's where the two overlap. So think, where are those two overlapping? Well, this is open and this is open, but they overlap everywhere in between. So when you graph x is in between 0 and 9, you start with an open circle at 0, open circle at 9, and you put everything in between. So it's important to know that this is the intersection of the two. This is where the two overlap. And means they both have to be true, right? Okay, so anything that's greater than 0 while at the same time being less than 9 would be included there. Okay, the next thing I'm going to do is rewrite x is greater than -2, and at the same time it's less than 3. Well, how can that be written without the word and? Well, I'm going to put x literally in between -2 and 3. Notice this includes x is greater than -2 right here, and this includes x is greater than 3. So when you write it this way, it's easier to graph, but we're going to go through the process. X is greater than -2 and x is less than 3. So I put my critical points. This is -2. This is 3. If something is greater than -2, it would go this way. If it's less than 3, it would go this way. So this would be where the two overlap. Where do they overlap? Where do they intersect? Right here. So this is graphed this way. X is in between -2 and 3. Okay, now number 3 says graph the solution set of y is greater than 5 and y is less than 3. I want everybody to try to do that now on your own. Try to graph that. Okay, so to graph this, first I'm going to graph the critical points. So I have -3 and I have 5. This would be y is greater than 5 over there. And then y is less than 3. And that goes this way. So that must mean this is what my final graph looks like. Does everyone agree? Do you guys agree that that's where the two of them overlap? That's where the two of them intersect? Thumbs up if you agree. Thumbs down if you don't agree.
I think she was muted, right? Yeah, she's muted.
Okay, thank you guys. I was muted. I was like, why is no one responding? Okay, so do you agree that this is y is greater than 5? Yes. Do you agree this is y is less than -3? But is this the intersection or the overlap of the two? Who agrees that I drew the last one correctly? Anybody? Thumbs up if you think I drew the last one correctly. Thumbs down if you don't think I did the last one correctly. Thumbs this way if you have no idea. Okay. I did not draw this last one correctly. And the reason is because I told you and is where the two overlap, right? Notice here for this one, they all overlap. Where do these two overlap? They don't, right? Because this one goes in this direction and there's nothing here on this one. This one goes in this direction and there's nothing here on this one. So graph the solution set of y is greater than 5 and less than -3. There is no solution. Who can give me a number that is greater than 5 while at the same time it's less than -3? And means both inequalities must be true. Can anybody give me a number that is greater than 5 and less than -3 at the same time? Anybody? No. So number 3 would be no solution. Okay, let's turn the page. And we're going to go through some of these. Okay? This says solve the compound inequality, then graph the solution set. So there's 2 ways to do this. I want you to first watch me do both ways, and you make a decision and only copy one way. I always think you're better just doing it one way. So one way to do this is to say, okay, I'm going to write 2 is less than y plus 6, and then I'm going to go this way. Y plus 6 is less than 8. So there's 2, this I'm writing now with an and. Remember I said you can write an and inequality with the word and or without? So I'm rewriting it so I have the word and. So here I'm going to subtract 6 from both sides. And then I'm going to rewrite this. Y is greater than -4 and I'm going to subtract 6 from both sides. Y is less than 2. So this can be written, it's greater than -4 and less than 2. So this is what it looks like. Now, another way to do this is to think of this as a three-sided equation. Whatever you do to the left, you have to do to the middle, and you have to do to the right. So I'm going to subtract 6 from the middle, which means I must subtract 6 from the right, and I subtract 6 from the left. 2 minus 6 is negative 4. Y plus 6 minus 6 is just y, and 8 minus 6 is 2. And notice I end up with the same answer, but this was just easier. And when I go to graph it, I say negative 4, 2, y is greater than negative 4, but less than 2. So this is the same as this, because and can be written with the word and it can be written without the word and. Okay? So now let's look at the next one. So number 2. I can rewrite this as 15 is less than 3x minus 3. You kind of go like that. And then I can go like this and say 3x minus 3 is less than 24. So I can either solve it this way by adding 3 to both sides. Say x is greater than 6 and add 3 to both sides. X is less than 9. So x is in between 6 and 9. Or I can say plus 3, plus 3, plus 3. I get 18 is less than 3x, which is less than 27. Divide by 3, divide by 3, divide by 3. 6 is less than x, which is less than 9. And that would be graphed the same way. So this is the same answer written 2 different ways. Okay, so I want everyone to try the next one, and you can do it either way, whichever way you prefer. So everybody do number 3 on their own. Okay, so I'm going to do number 3, but I'm going to do it the way I like to. And I like to just do it this way. I subtract 1 from all 3 sides. I get 14 is less than negative 7x, which is less than 49. Now I'm going to divide by a negative 7. And what do I have to remember when I divide by a negative number? I have to remember to change the direction of my inequality sign. So I'm left with x is in between -2, and -7. But I'm going to rewrite this because I always like my smaller number on the left. So if x is in between -7 and -2, it's greater than -7 but less than 2. So when I go to graph it, I have -7 here, -2 here. So just be careful. I mean, never put -2 to the left of -7, right? So thumbs up if you got that one right. I want to see how many people got it right. Okay, and if your camera's not on, turn your camera on because I can't see if you have thumbs up or not. And you don't want me taking a point off from your homework grade, do you? Okay, so now number 4 says graph the solution of x is greater than 3 and x is greater than 5. Okay, so here, first I'm going to graph x is greater than 3. That's pretty simple, right? X is greater than 3. Now I'm going to graph x is greater than 5. And now I know the word and means intersection or overlap. So where do these two overlap? Where are they both covered on both lines? Okay, Shashank said past 5. He is correct. So this is the intersection. X is greater than 5. So if you have x is greater than 3 and x is greater than 5, that is what we call, well, it's not redundant, but it's not clear what your answer is. If x is greater than 3 and x is greater than 5, your final answer is x is greater than 5. And if you write this as a final answer, it will be marked wrong. Do you understand why it'd be marked wrong? Because it shows you don't understand that if your answer is x is greater than 3 and x is greater than 5, your final answer is just x is greater than 5. Because it has to be greater than 3 and at the same time greater than 5. Is the number 4 greater than 3? Yes. Is the number 4 greater than 5? No. So this would not be your solution because it includes numbers that are not included. Okay? So let's turn the page. And we're going to go over some or inequalities. Now, or is different from and. The first big difference between and or is that an or inequality can never be written without the word or. If you don't see the word, okay, Nitty, oh, there you are. If you don't see the word or, then it's not an or inequality, okay? And an or inequality is the union of the two graphs as opposed to the intersection. I want you to think of or as the inclusive inequality. Everyone is welcome. Or is inclusive. Okay? And is exclusive. And is like the Mean Girls table. And is you can only sit here if this and this and this, and I can kick you out for whatever reason. Okay? Or are the UMS middle school students table, because UMS, we are all We all have empathy. We all know everyone should be invited. We're not going to exclude somebody just because of this, this, or this, okay? So or is very inclusive and is very exclusive, okay? So let's go over some or inequalities. So you see here where I say x is greater than or equal to 5 or x is less than 5 cannot be written like this. This means and. If you don't see the word or, and is implied. So now when I graph x is greater than 5 or x is less than negative 5, here, this is what it looks like. This is your final solution. Now, do they overlap? No, they don't have to overlap because this is or. Or means if it shows up on this line, it has to show up in your final solution. If it shows up on this line, it has to show up on your final solution. Okay? So now this is a little harder because I'm not in person, but everybody look at me. Okay? And camera's on. I want everybody to do this. Grab your elbows and go like this. This is an and inequality. We overlap. Where our arms overlap is the solution. Our elbows are the dots. This is and. Okay, or looks like this. Everybody goes like this, okay? Or one's going this way, one's going this way. Okay, so or and. Everybody go or and. Okay? Now,
As Chandra said, this is or?
that's and. Everybody look at Arhan. Do it again, Arhan.
So this is and?
That's and. Now show us or. Yes, that's or.
Okay.
Okay? Now, okay, we are going to, now, because this can't exist without the word or, we should always have the word or written when we're solving this. There's only one way to solve these. So, I'm going to solve the left-hand side, and I'm going to solve the right-hand side. So the left-hand side, I'm going to add 5 and add 5. So this becomes 4m is greater than 12. Divide by 4, divide by 4. M is greater than 3. Or, and now here I add 5, add 5. 4m is less than negative 4. Divide by 4, divide by 4. M is less than negative 1. Okay, so my final answer is m is greater than 3 or m is less than negative 1. If you write this on your answer line, you will get no credit. Who can tell me why? You will get no credit if you write this on your answer line. Jane?
Because it's incorrect.
Why is it incorrect?
Because m is greater than 3 and not less than 3.
Oh, okay. You're right, but I didn't do that on purpose. Okay, suppose I wrote it like this. Suppose I wrote it right. Why is it still wrong? Josh? Joshua?
I think it's still wrong because it doesn't have or in it.
Exactly. If you don't have the word or, it's wrong. 100% wrong. Because if it's an or inequality, you have to have or in the answer. Now, when I go to graph this, I put my critical points, -1, 3. M is less than -1, or M is greater than 3. Okay, Arhan, use your arms. Show everybody what an or looks like. Come on, because everybody can see you better than me. Perfect. See, it's going in both directions. Okay? Now, let's look at number 2. So I'm going to make sure I have that word or written down. So I'm going to write it like this because I know or will be included. I'm going to add C to both sides. I'm going to divide by 2, divide by 2. So C is less than 3, or 2C is less than 14. C is less than 7. Now, if I was to write C is less than 3 or C is less than 7 on my final answer, that would also be wrong. And the reason that would be wrong is because it shows I don't really understand or inequalities. Let's see what I mean. If I was to graph C is less than 3, it would look like this. If I was to graph C is less than 7, it would look like this. Or is inclusive, or includes everybody. What should my final solution look like if I'm including everybody? Both C is less than 3 and C is less than 7. Got it?
C is less than 3.
Okay, so if I write C is less than 3, are you including the number 6?
No.
And is 6 less than 7?
Yeah.
So did you include everybody?
No.
So what should the answer be?
I'm not sure.
C is less than 7. If this was an and inequality, if this was and, we wouldn't count this one. But for or, we include everything less than 7. Because remember, if it exists on one number line, it has to exist on the final. So the final answer for this would be, on your answer line, it has to say C is less than 7, and the graph would look like this. Okay, if you wrote this on your final answer line, it would not be marked correct because it shows to me you don't really understand. So this is, again, harder to show because let me try to back up. This is a good visual. Okay, so everybody can see me. This is and. Everybody do and. And, or. And, or. Now, when you have these kinds of inequalities where it's like they're both going in the same direction, you do or is more. Everyone go, or is more. Or is more. It's going to look like this, and you include everything. With the and, you only include from this elbow on. You only include the overlap. Okay? So when you're confused and deciding, should I include the overlap or not, you say or is more. When it's or, you include from 7 and that direction. If this had been and, Because or is more, you would only include C is less than 3. Okay, now let's look at the next one. Okay, the next one, I'm going to solve over here so I have more space. Negative 1 plus x is less than or equal to 3, or negative x is less than or equal to negative 4. So this becomes x is less than or equal to 4. And here I divide by 1, change the direction of the inequality sign. So my final answer is x is less than or equal to 4, or x is greater than or equal to 4. So this includes less than or equal to 4. This is greater than or equal to 4. So where is the union of the two? If I was to include everything on both lines, it would look like this. So if your answer looks like this, what's the best way to express your answer? Nidhi?
All real numbers.
Perfect. So you would not write this on your answer line. You would write this. Now, sometimes or is all real numbers. Sometimes and is no solution. I have not yet come up with a situation where an or is no solution, and I've never come up with an and is all real numbers. Okay? So in general, if you end up with all real numbers, it's probably the result of an or, and if you end up with no solution, it's probably the result of an and. Okay?
Miss Charmis,
Yes.
when you say like all real numbers,